through projects. In this video, we are going to explain about the project that is enhancing user experience on question and answer platforms, measuring text similarity based on hybrid CNN LSTM model for efficient duplicate question detection. Before getting into the execution, first let us understand what is the project about. Imagine you're working on a coding problem and you're stuck, and the first thing you think of it is to hop onto Stack Overflow. It is like this massive, that super smart friend who always has the answers. Since it started back in 2008, Stack Overflow has become this giant community that millions of people asking and answering questions about programming every single day. It is not just a forum, it is a powerhouse of information with over 18 million questions and even more answers and comments. But here the thing is, with so many people asking questions, duplicates are bound to happen. Think about it. You ask a question, and instead of finding one clear answer, you end up padding through a bunch of similar but slightly different ones. Frustrating, right? It clutters the whole experience, making it makes findings answer harder and even waste storage. That is why dealing with duplicate questions is such a big challenge for platforms like Stack Overflow. They want to keep everything clean, efficient, and helpful for everyone. So when you're trying to find an answer to a question on Stack Overflow, you don't want to waste your scrolling time scrolling through multiple almost identical questions. That's where detecting duplicate questions comes into the play. It sounds very simple, right? But it is a tricky. It is a bit tricky. A lot of times the questions are short, like it may be of just few words, and those tiny queries can be messy. People might use slang, their own slang, spell things creatively, or just phrase things in really informal ways. This makes it tough for traditional tools to figure out if the two questions are actually the same or not. Here, on top of that, when you are analyzing these questions, you need to look at different layers of the meaning. For example, there's the way the words are structured. That means you need to look at the syntax and what the actual meaning of the word, that is semantic. You need to look at semantics of the text and how they are being used in the context, that is called pragmatics. So it's like trying to understand not just the words but the intention behind them. With all these challenges, we need more advanced techniques to make sure we are catching all those duplicates and making the platform easier to use. The goal is to help users find what they need faster and with less confusion. So it is a really important problem to solve. So the project that we are talking about is designed to solve the problem of duplicate questions on the platforms like Stack Overflow. When users post questions, often similar ones pop up over time. So our approach combines two powerful machine learning models. So here in this project, we combine two powerful models, that is CNN, convolutional neural network, and long short-term memory. First, the system takes the text of the questions and uses natural language processing, that is NLP technique, to clean it up. That means removing unnecessary words, fixing spelling mistakes, and simplifying the language using methods like lemmatization and stemming. Think of it like tidying up a messy room to make things clear and easier to work with. Once the text is clean, it gets converted into numbers using something called word to vec. So here we have used word to vec, which is important because computers can't understand the text that we do. So word to vec turns out the words into numerical vectors that capture their meaning in the context. This helps the model better understand what the question is actually about. With all this pre-processing it in place, the system can use the CNN and LSTM model to detect duplicate more effectively by analyzing patterns in the context. So after this, what do we do is we combine CNN and LSTM, which is good at spotting small and local patterns in the text, like specific words or phrases that are used similarly across different questions. On the other hand, LSTM helps the word to understand, that is the system to understand the bigger picture, how words and phrases relate to each other over long stretch to the text. It is like CNN focuses on the details and LSTM looks at the overall context. And here the system processes data using this word to vec for text embedding purpose. For testing, the data set from Stack Overflow that contains pairs of questions, each is labeled as duplicate and isolate, has been used. So the data, questions of the Stack Overflow have been taken from the Kaggle repository. The system performance is measured using metrics called accuracy, precision, recall, and F1 score. So these are the metrics used to evaluate the all the algorithms trained. So these measurements tells us how well the system is doing at identifying duplicates, reducing unnecessary repetition, and ultimately making the platform more efficient and user friendly. So this is the proposed system. Moving on to the extension part to further improve the accuracy. Here, what we're doing is we have incorporated advanced algorithm called CNN2D with a bidirectional LSTM, bidirectional and LSTM. The CNN2D model it sets up from the regular CNN because it works with the two-dimensional arrays, allowing the system to extract features more efficiently. It helps in keeping the important features and discarding the irrelevant ones. Once the model making the model more precise. By combining CNN2D with bidirectional LSTM, the system benefits from not only optimizing features in different ways but also handles data better, leading to improved accuracy in detecting duplicate questions. On top of that, we have built a user-friendly front-end using Flash framework. This interface is isn't just for a show. It allows users to interact with the system, test its performance, and ensure everything is working as expected. Plus, with the secure authentication, users can log in and use the system safely. This makes it not only efficient but also accessible, providing a way for users to see how well the system performs in practice. Moving on to the implementation. To implement this project, we have followed the steps mentioned in the flow of work. So, first, we have imported all the necessary libraries and dependencies such as TensorFlow, Keras, Pandas, NumPy, and others which are required for data processing, model building, and evaluation purpose. Then comes exploratory data analysis. In this step, we explored the data set to understand its structure, checking for missing values, and analyze patterns, and get insights into the data distribution and relationship between variables. Coming to data visualization, here we use various visualizations. We visually represent the data to gain deeper insights and identify trends or outliers that could impact the model performance. So here we use charts and graphs. Then comes text pre-processing. So here this text pre-processing involves preparing the text data for analysis and it includes removing stop words. That means we remove common but unimportant words like the, and, is, and etc. Coming to stemming, here we reduce words to their root form. That is, running word becomes run. And then we apply lemmatization. Here we convert words to their base or dictionary form. For example, better becomes good. Then comes text embedding part. So here we use word2vec to convert the pre-processed text into numerical vectors. This transforms the textual data into a format that machine learning models can process while preserving the context of the words. Then comes splitting the data set. So the data set is divided into training and testing sets. The training set is used to train the model while testing set evaluates its performance on unseen data. Coming to model defining, in this step we define the architecture of the model, that is machine learning models. It includes setting up layers, activation functions, loss functions and other components necessary for model building. And then comes model training. Here, the defined model is trained using the training data set. During this phase, the model learns patterns from the data by adjusting its weights to minimize the error. Then comes model evaluation. After training the model, we evaluate its performance on testing set using metrics like accuracy, precision, recall, and FN score to check how well it predicts the unseen data. Then comes performance comparison. We compare the performance of the trained model with the other models and the algorithms to determine which one performs the best and which is the most suitable for this task. Coming to frontend, a user-friendly interface is developed using Flash framework. This includes setting up features like user registration, login, and connecting to the SQLite database for storing user information securely. Then comes user gives input. So here in the front end, users they provide input to the front end interface, such as entering a question to be checked for duplication, and that will be pre-processed at the back end. It will be fed with the trained model. Finally, outcome will be displayed through the front end of the application. Moving on to the algorithms used. These are the algorithms which are used to train the model for checking the similarity between questions. So we have used SVM random forest for the comparison purpose. This is the proposed model and this is the extension model. Now moving on to the requirements. To implement this project, we need basic requirements which are hardware and software. Coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and hard disk of 25 GB. Coming to software, we need application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap. So this is the overview of the project. Now let us execute. To execute, we are supposed to open the code folder that contains source code files. So let's open that. These are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So the first folder which we have is the dataset folder in which we have dataset. So this is the dataset used in this project. Let's open that. So here we have question one and question two body, and here we have the target class. This we will be predicting in this project, and we will be using this data to train the model. Let's close this. And here in this file, we have the test data, I mean test cases that we will be using in the front end for predicting the similarity between the two questions. Let's get back. And here in this model folder, we have algorithm information that is stored in .h5 files, numpy files, and pickle files, which will be loaded into the project code during runtime. And here we have static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. Then we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represents the different pages of the website. And then we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is a signup.db file. This file is a database file which is used to store the user information. So this is about the code folder. Now let us execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying the path. So copy it. Now open command prompt. It has been opened. Give the command cd, give the space, and paste the copied path. Now click on enter. So by giving this command, current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the local host and the port unless configured differently. So this is the local host. This is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I'm copying it. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to sign up first. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in and give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. Here you can see a choose file button, right? We need to click on that for uploading the test case file. Click on that. So this is the file that we will be uploading now. Select it, click on open. It is loaded. Now click on upload. So this given information, it will be pre-processed at the backend. And then that pre-processed text, it will be fed with the train model. Train model will be giving us a prediction. So here we got the prediction. So before checking with this prediction, let's see what do we have in that test data. Let's open that. Open the data set, open the test data. So these are the different inputs that we will be giving now. So here we have question one and question two body. So these we will be giving. So if we give this first case, we will check whether they are of similar kind of text or the isolate. That means they are unique. Let's get back to the application. So this is the first text that we have given. This is the question one and this is the question two. I mean, this is the question one body and this body is the question two body. With this, we can understand that the predicted question type is duplicate, which means that they are of same meaning. So these two questions are of same meaning. With this prediction, we can understand that they're of same meaning. And coming to the next question, that is next test case. So this is the test case that we have given. So here are the two test cases, I mean two question bodies. So this is the question one body and this is the question two body. With this, we got the prediction that isolate. That means they both questions are of different meaning. They are not similar. And for the next one, this is the first question body and this is the next question body. So here we got the prediction as duplicate, which means they are of similar meaning. And for this case also we got duplicate, and for this case we got duplicate, and for this case For this case, we got prediction as isolate. That means both the question bodies are unique. Similarly, for all the cases that we have given here, we got the prediction. If they are of same type, if they are similar, we get the prediction that it is duplicate. If they are unique, we get the prediction as isolate. So this is how you need to execute. Now let's check with the graph. Click on graph. So here we got the graph. This is the extension models confusion matrix, that is CNN 2D bidirectional LSTM graph, and this is the ROC AUC curve graph. Here on x-axis we have false positives and on y-axis we have true positives. And this is the accuracy score comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms which are trained for checking the similarity between questions. And this is precision score, recall score and FN score. Accuracy, precision, recall, and FN score are the metrics used to evaluate the all classification models. Now click on sign out. In this way, just by giving text to the application, that is, we are supposed to provide the question 1 and the question 2. I mean both the questions. If the questions are similar, the application will predict it as duplicate. If they are isolate, I mean if they are different, it will predict it as isolate. That means they are unique. They are of two different questions. They are not of same meaning. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.